Hi. All right. Hi to everybody on the call. I'm Justin. I work at Parity Technologies as a solutions engineer, and today I'll be giving an intro to Substrate, which is a blockchain development framework. All right, so to do that, I'm going to take a few steps back. First, I'll introduce myself. We'll talk about what Polkadot is, because that's kind of a big piece of context when we're talking about Substrate and why Parity made Substrate. Then we'll get into what Substrate is, why it's special and you might want to use it, who uses Substrate. Before we get into a demo, we will talk about how you start a Substrate project and the kind of the file structure that you'd expect in a typical Substrate project. And then we'll finally build a proof of existence blockchain, or see as how far we can get. If we run out of time, I'll just stop and we'll walk through the solution code. We'll demo it and then we'll run through any questions that you guys have. Though if there are any questions that come up while we're writing code, I think that's also a great time to ask those ad hoc, or just any ad hoc, like sort of blocking questions. And then we'll talk a bit on how to get started, where to go from here, if you're interested in starting on Substrate. Okay, so who am I? I'm Justin. I am a solutions engineer at Parity Technologies. Parity is the company building Polkadot and Kusama and Substrate. Before Parity, I was doing a bit of freelance blockchain development, kind of some freelance, some NFT focused blockchain stuff. And before that, I was working in Web 2, just doing like full stack software development. That was before I got into Substrate. And I'm pretty interested in like some hybrid on off-chain, pretty algo-y projects that are involved with like game theory and stuff. And this is the kind of good place for Substrate to fit in, and that's one of the reasons why I ended up choosing Substrate, and why I got so into it. I did mention I'm from Parity. This presentation is not sponsored by Parity. This wasn't put on by Parity. My slides are going to suck. You know, for that reason, this is just kind of me putting slides together. But I did want to give that background. So starting with Polkadot, we have to start from here when we're talking about Substrate, because it's how we got to building Substrate. If you haven't heard of Polkadot, it is a blockchain. It is at one time both a protocol and a network. It's a protocol in as far as how the code describes its consensus and finality, and how it describes these communications between nodes. And it's a network made up of all the validators, nodes, the collators that make up the Polkadot network. So that's just kind of a naming thing. We talk about both things when we say Polkadot. It's multi-chain by default. So what does that mean? So Polkadot aims to be the first heterogeneous sharded blockchain network. What that means is Polkadot exists as a blockchain, but it has a protocol that allows other blockchains to lease slots, which are essentially places on the Polkadot blockchain, where they plug in, so to speak, and they can share Polkadot's security and secure message passing. So Polkadot kind of sits above, and all these blockchains can hook in, where they all together form one sharded network that once together is more scalable and a unique and useful ecosystem, because not only is it a scalable network, but it's one with all these different functions made up of these heterogeneous or different blockchains. So looking at this super simple, actually confusing diagram, we have relay chain written here in the middle. Hopefully you guys can see that. I'm not able to zoom in. This is the relay chain in the middle, which a relay chain here means Polkadot, a blockchain that can share its security and messaging amongst other blockchains. And here, these other diamond spaceship looking things, these represent the other blockchains that have leased slots in the relay chain, and they're plugged in. So these are all blockchains that can communicate.
Justin, could you explain what sharding is?
Sure. Yeah. So sorry if I missed a question. So sharding is a strategy to scale a blockchain. Sharding involves splitting or partitioning a blockchain somehow into different pieces. And it's just that the strategy that Polkadot has gone with involves using pre-existing other blockchains that can be unique as they come, different consensus, different finality, different state transition functions. And it's scalable because these blockchains that sit under Polkadot have their own ways of coming about their own consensus. And Polkadot does less work on its end because it has a method of importing those blocks, reading and verifying the state transition functions of these other blockchains that plugged in, verifying those, and then validating its own blocks as it does its own work. So it's almost like this abstraction where like there's a lot of work that can be done on these other blockchains, but the pieces of information and computation that matter to Polkadot are the pieces that bubble up to Polkadot, i.e. the blocks that are imported by Polkadot from these other chains and the messages that are passed in between Polkadot and these other chains.
One question was, can you give an analogy, a real analogy if possible?
I can do my best. I heard one in a speech the other day by somebody else in the ecosystem. And I this one kind of vibes with me a bit. So say you have two countries. Okay, so one is like a republic. So it has states like Texas and California, all these different states with different geographies and different state level laws that are governed by federal laws up top. And then your other country doesn't have states. It's, in this case, like what we'll pay attention to is like, we'll say in both cases, there has to be some consensus on like votes for laws. Like in the case of the Republic, the federal law has less concerns of some of the smaller jurisdictions, and it concerns itself more with like working on federal laws, and then the states vote on their own laws, and some of these decisions bubble up to the federal level. And so we don't need to like gather consensus from a huge amount of people all across this country for every matter. Some of those concerns are kind of split up. Whereas with this other country where it's less of a republic and there aren't states, we're saying like this is a blockchain that hasn't sharded into these different or heterogeneous shards. And for every action, every law, every single person needs to come to consensus on all these different motions. I'm simplifying it a little. This isn't quite how like consensus or voting works in like any realistic country, but I'm trying to draw that there's these different levels of consensus that we might need to come to for different actions. So I hope that helps. I think I drew it out quite a bit. But that's one of the best ways I can explain it. But you feel free to throw any more questions in the chat, or ping me after, and I'm completely happy to answer any follow-up questions. It's an ecosystem, so there's an ecosystem of the different blockchains, which makes up Polkadot's network, ecosystem of investors who are also participating in governance. Because there are governance measures on Polkadot. If you're a holder, you can act in its built-in governance. And there's also the builders on Substrate. Maybe I did mention that, but what that also includes is not only these developers who are working on these parachains, these are called parachains, these connected chains, but people who are developing their own blockchains on Substrate are also part of the same ecosystem. We're all building modules that are useful to one another, like DeFi or DAO or smart contract modules. So whether or not you're really in Polkadot or you're building outside of Polkadot, building your own chain, we can all kind of contribute and work on the same problems and share and help each other. And then finally, I have this point, it's built with Substrate. So the team, starting with Gavin after he had built Ethereum and smart contract language, and the first parity guys after they were building proof of work and creating proof of authority, building proof of work blockchains and coming back, building proof of authority. There was this repeat work. So they found that there were these abstractions to blockchains that they needed to create so they're not repeating a lot of work. And to avoid this problem of existing code bases being forked, and then like the modules inside weren't as plug and play as you might like in like a framework with a nice abstraction. So they decided to create Substrate. So Substrate. Substrate is a framework for building blockchains. This is a bit of a different model than you might be used to, coming from different ecosystems, depending on what part of the multiverse you come from. But the focus is L0s. And Substrate's goal is to empower you as a developer to build blockchain runtimes. The target is a developer who's not going to work so much on consensus or networking or transaction queues or all these like no-brainer parts we can expect that would be a part of every blockchain. I see a question, does Polkadot talk to a smart contract on each of these? No, so it's not a smart contract. There is some built-in networking there. And so yeah, it's not a smart contract. And I was gonna maybe wait on this one a bit because I am going to kind of talk a bit on how smart contracts fit into the picture of Substrate. So thank you for the question. I hope I can answer it more, especially on the smart contracts part. So Substrate is focused on helping you build this runtime layer, which is the state transition function of the blockchain. So, it's the function that once compiled, it describes how everybody comes to agreement on the transition of the shared state of the blockchain from one block to the next. So put simply, if you're working on like a smart contract blockchain, you're writing functions like upload or instantiate smart contract or execute smart contract, as well as any other customizations that you think would make your smart contract functionality unique. It's Rust native. So if you're writing Substrate, you're writing Rust. I think it's pretty beginner friendly. For example, I started building Substrate without knowing Rust. I hit trouble. I went back to read the Rust book. I got up to like chapter 10 or 12, and then I came back after doing that and writing an example project, and I felt really confident, and I was better able to move through some of the Substrate documentation and examples. And it's exceptionally modular. So again, we're not like forking a code base of a blockchain that wasn't written as a framework. We're able to plug and play different modules that are purpose-built for blockchains. So there is a module for smart contracts. There's one for EVM, there's one for WASM smart contracts, there's DAO and governance and DeFi smart contracts, and you're able to plug and play and configure different values that the developer of those pallets has exposed to you. And this extends further down, like not only inside of the runtime, you're able to plug and play things down to the consensus level too. But just to talk a little bit about this architecture here, this little diagram is meant to give you a picture of how the Substrate node, how it works. So you have the runtime, the state transition function. So your smart contracts, your balances, assets, all of your blockchain specific stuff sits here. That's normal for a lot of blockchains. But again, here the focus is on building and customizing that. This is what you write in Rust. And this is compiled when you're running a node, it's compiled down to WASM or WebAssembly, if you're not familiar. WebAssembly is a cross-platform target. Which is really useful for a blockchain because there's a heavy focus on determinism, right? We want things to work the same everywhere, and that's something that WASM is really good at. And this allows us to do really interesting things, like we have built a Substrate node that you can run in a browser, and this enables things like truly decentralized web apps, things like that. So moving a layer down from the application layer, we have some of the pieces that come boilerplate and Substrate, a lot harder to change. Like for example, if you're going to switch consensus out of your in and out of your Substrate runtime, you're going to do a lot of work, and we would expect like a really advanced developer who's worked with consensus to do this sort of thing before. Same with storage, the database, the fork choice or finality, transaction pool, networking. And then there's some other pieces that make up the node. libp2p library is what powers the networking of nodes, and JSON RPC for API endpoints. Okay. So moving on. I want to talk a bit about why Substrate is a bit special, now that we've kind of introduced it at a high level. So the feature that was most interesting to me, and it's probably my favorite feature, is forkless upgrades. So you might know in a lot of blockchains, upgrades to the code take months or years of planning and execution, and you might need a hard fork depending on like how backwards compatible your changes are. But Substrate allows you to upgrade instantly. You upload a WASM blob, you might write some code so that it sits behind a governance decision or some vote or whatever you want your users to decide. But beyond that, it's instantaneous, or at least within a block. So there's a wide variety of modules that are available for some super common use cases. These are developed by Parity, and the community also develops and puts out pallets as they develop different chains. So for example, there are some DeFi like Atomic Swap and loans and other actions, DAOs and governance. There's a slew of pallets that are available. Smart contracts, I mentioned that there's EVM, and there's also WASM smart contracts, which is something Parity is spearheading. Identity pallets, fungible and non-fungible tokens, and pallets that give you access to off-chain workers. So that's essentially an Oracle and in other ecosystems. Some pallets give you access to that out of the box. So interoperability. So Substrate is built to give you the option to easily convert to a parachain. And if you remember, that's the type of blockchain that has least a slot in Polkadot or other relay chain and can send and receive those messages to all other connected chains. So it's really easy to do that if you're developing through Substrate. And what that leads to is something we haven't really seen before in blockchains, and that's some concept. It has no name, but I called it composability of cross-chain interactions. Like if you're writing a pallet, you can, and you're hooked in as a parachain, you now have freedom to interact with any number of chains that are connected to Polkadot. So say if you're a metaverse pallet or a chain and you like want to talk to an NFT chain over here, and you need to talk back to an identity chain, smart contracts, you can write functions that compose these other chains and their different functions into yours, utilizing their extrinsics that access the data on their chains and the accounts over there and whatnot. So that's going to create some really interesting interactions as more chains lease slots on Polkadot. I also didn't mention that there's bridge pallets, but one point I wanted to make, and I'm sorry to backtrack, but one other reason why this model is useful is because if you want to connect to a number of other chains, you could create n times n bridges. And a single bridge is really difficult, and there's a lot of security implications. But if you plug into one slot here, you have that many connections to all connected chains. And so that would save you a lot of work. So a few more on why Substrate is a bit special. So I mentioned it comes with blockchain no-brainers. So the focus is on runtime development and all facets of documentation and support in Parity's materials is focused on this area. And so, like I said, Substrate comes out of the box with everything you need, and those resources are heavily geared towards making you as successful as possible in this area, as opposed to focusing on problems that may have already been solved. And then there's more freedom of development if you're building your own layer one. Even though you're able to hook in and essentially create something that acts as a dApp or have some application interface like you would with Substrate development, you have the full freedom of your own blockchain. So and you have the freedom to modify all existing pallets. A bit more difficult than configuring them, but like say you want to create smart contracts that have some ZK functionality. You can, if you have ZK functions in your runtime, you can expose those through some configuration to your smart contracts, and they all have your ZK functions available, and they can utilize those. And you can do similar things like being able to make your smart contracts. You can write or configure them to talk back to your runtime. You can create feeless transaction applications depending on your use case. So the your freedom extends not only to like the runtime level, the consensus level, but like the existing pallets and, you know, your ability to innovate within these different levels is really much greater than a lot of existing options. Who's using Substrate? Who uses it? So there's 150 plus projects right now who are building on Substrate. That's not limited to Chainlink, LF0 Engine or Affinity, Energy Web Foundation, and Moonbeam. It's the second largest developer community after Ethereum within the blockchain space, counting full-time developers. And maybe you, if you're interested in Rust, know some Rust, or have some blockchain experience, and it might be a good fit if any of this sounds interesting to you. Okay, so we'll get into a quick example of developing on Substrate. I want to first show you how to start a project. So I'll show you the Substrate node template. I want to walk through a bit of the structure of a Substrate project, and then we can work on the example that I wanted to work on, though we're about halfway through. If we don't finish it, then I have some solution code that I might run through quickly and show you the app interface. But I think I can at least show you the core pieces in terms of time. So your first step in starting a Substrate project is to clone the Substrate node template. So you can clone it, or you can click use this template. This is a template repo. So clicking this button is essentially like, it's kind of like, it works kind of like a fork, like it puts this template over to your repo and you rename it. And this is not quite the same as forking a blockchain, because this is a framework and there are modules in here that, thank you for linking that, Banjo. Banjo pasted the link in the chat. And I'd also like to share these slides with everybody, if that's okay. I have a few links in the slides. So your first step is to clone this. And then you're off to the races. So just to talk about the structure a bit here. Sumit's asking for a starting point. Sure. So a good starting point is the documentation. There are quite a few tutorials here in the Substrate docs. And the tutorials walk you through each of these steps that I will, that I'm showing you now. They show you how to clone it, how to get all the Substrate dependencies, getting Rust if you don't have Rust on your machine. And they walk you through these different use cases. Like first is just starting your chain, then you add a module or pallet to your chain. And you know, you have other tutorials that are like the one that is more or less the exercise I'm showing you today. But the docs are really useful. This is for certain the starting place if you're getting started with Substrate. I'm sorry if I'm rushing a bit. I haven't done this presentation, and I do have a lot of things I'm trying to show, so I apologize in advance if I seem rushed. But I do want to talk through the structure of a project before we dive into some code. So you have the runtime. I mentioned the state transition function to you before. This is the part of the code that takes all your modules or your pallets and compiles them to WASM and describes the application behavior of your blockchain. In most cases, the runtime just looks at different pallets or modules inside the pallets folder So we'll start there. The pallets folder just contains different pallets by name, where each pallet is just a Rust crate. If you're familiar with Rust and crates, a crate is a module, essentially, where these are library crates. So just walk through a bit of code, and then I want to show you a few important pieces that are part of every pallet, and then we can look back at the overall structure of the project. So each pallet declares no STD. The standard library cannot be used in our pallets because we are targeting WASM. And this doesn't contain some of the system or lower level APIs that standard libraries expose. We use this Rust macro to tell the runtime that we're starting a pallet, which we declare with this module directly underneath. And then I want to jump to some of these other macros underneath. So this first macro, config, is where you place configurable types for your pallet. When you're writing a pallet, you want to think about how other developers might use it in the future. Some values you might know the type, or you might know how it needs to be represented. Others, like for example, if you are creating a balances or assets palette, you might want to give the developer the option of how a balance should be represented, for example. So you would write the type for that there, and then the developer who's using your palette in the future would pass a different type, would configure the type differently in their impl of the config. Impl is a Rust word. It's basically how you implement something called a trait. Events, this is the section where you define different events that you need to show the UI or any observers of the chain. So in this case, we're looking at a solution for the code example that I wanted to show you, which is okay. They've defined these events where a claim, or in this case, they're representing a file or file hash. They're saying that one was created, and we're showing to the user the account ID of the person who enacted that, as well as this is a string. It's an encoded string based on a codec that we use in Substrate that's called scale. And both of those pieces of information, the account ID and the string, are shown to the front end. A similar case for the opposite, where a claim is revoked or removed. You can define errors in this enum. In this case, an error, it's kind of, it should be declarative by name, like its name should describe what it's doing, but you might also give it some useful doc comments. Some required boilerplate, and then you define storage, which is an important part of any blockchain or application you're building. You need to create some storage. In this case, Substrate works off of a key value store, so you can create single values, like if you want to store an ID for something that you'll refer back to, you might use a storage value, or if you want to store a list of account IDs, you might use a storage value. If you want to create like a key value mapping, then you would create what's called a storage map. This is all in documentation. Nobody memorizes all this syntax. For writing all this, it's a lot. You've got like your decision of your hashing function here. So nobody remembers how to write all this. It's all in the documentation. But one key thing here is, like, if you're writing a key value store, your key is here and your value is here, both in the middle. Hooks, I will not cover. And then finally, before we can get off this topic, you have your dispatchable functions or extrinsics. These are functions you can call from outside of the blockchain. So if you're writing a UI on a chain, that UI can invoke these functions. So here they've written one called create claim, and create claim takes an origin, which is a signed or unsigned representation of the caller. So that can be an account or wallet who signed a transaction. It can be an unsigned transaction, or it can be a root level origin. Following that required argument, there's any number of arguments that you want to pass into the function. I'm gonna stop there, and because I want to make sure there's enough time to get into the code and talk about it piece by piece. So I'm gonna stop sharing that, and I'm gonna share my code here. And hopefully that's big enough. Can you guys shout out in the chat box?
Looks good.
Great. Perfect. Thank you. So let me make sure my code's correct here. I need to real quick check out the code because I was just trying to implement the solution a second before this. Okay. So here I have in my palette, which again is just a module, like some piece of functionality that makes sense to group together in a blockchain context. This is the boilerplate version of the palette template. So what we're going to do here is we are going to try to implement some store of file authenticity, or we're going to see how far we can get before we start to run out of time. So the goal for this system or the design is that we are going to imagine that there's a UI somewhere for this app, and this UI accepts file uploads. It takes the hash or digest of that file, sends it over to our chain, and then in the chain, we are going to take that hash, tie that to the user who submitted it, as well as the block number it was submitted with. So essentially, we're going to take the hash of a file as a key and tie it to a user and one other piece of information, like the block number where it was submitted. And this is useful because this can say, hey, this piece of content, this file hash is unique or specific to this user. So you might use this to denote ownership if you're creating some sort of like file sharing service or NFT-like platform. You might start with a design like this. Okay. So the first things first, we want to focus on the storage. We're going to design some storage that allows us to take the accept the file hash and tie it to the user in a key value store. So this part is the one piece that I will copy and paste. I don't have it with me. I think I closed the window that had it, but it's okay because I can remember the gist of the syntax to declare this. Like I said, nobody remembers this offhand. I kind of remember because I had to write it when I was prepping this presentation. But we're going to declare this type as public, so it's available outside this this module, and I don't think we need to do that. We're going to declare the storage as public, and it's a key value store of file hashes to users. Let's call it claims. Okay, we're essentially saying that this user has made a claim of a specific file, and we can say that file is unique. So this, the storage is generic over T, which is just in the context of a pallet, this T represents the config for our pallet, and the config is this. But this config gets a whole bunch of other values, which you'll see in a minute. We're going to create a storage map. And you see my IntelliSense as a type that allows you to store value for given key. So that seems like what we want. And then we're going to add a bit of boilerplate. Don't need to memorize all this. This part is required due to some design of how the storage map works. This is a hashing algorithm for the key value store. And finally, we can define the key that we want for the storage. So I'm going to say that my key is the file hash. We want a key off of the file hash, right? It needs to be unique. So I'm going to put something weird here. We're pretending that the UI is sending us a string of the file hash. And you see I put a vector, which is like an array. If you're coming from other languages, it's like a growable array with a few other useful methods that contains U8 integers. And this is just a something that's specific to the codec that's used in Substrate. Strings are represented as vectors of U8s. So that's just kind of an oddity. For the most part, other types are all the types that you might expect, and you can interact with them as such. Strings are just the one that's a little bit weird. Okay, so now we said we want to map this key of the file hash to the user and the block number. So in this case, we can do this. Substrate places the account ID type on this generic config value, which we've exposed through T. And then similar thing for block number. Okay, so we've created a tuple here of account number and block number. And if that doesn't quite make sense, I'm going to demo this all in a second because we're running short on demo time, and I'm going to cut to the front end DApp interface so you can just see how it works. And then the last piece we need to create the storage is value query. Okay, so that's a quick overview of what writing a storage item looks like in Substrate. This concept is also well documented in the Substrate docs. I'm going to cut over back to my screen really quick and show you guys the solution as well as the finished DApp. Okay, so this branch holds the solution for this exercise. This exercise came from a Substrate tutorial. So what these guys did is they created two events, one for claim created and claim revoked. We went over this. They created a few errors that can be used in the runtime. Proof already claimed is the critical, like that's the key one here. Because if we're creating a system where nobody else can claim another person's file, like each file is unique to a user, we need some indication that a file was already claimed by some user. So that's why that error is useful. They created a storage item, which looks kind of like ours. It looks like we kind of got it right. They called it proofs. I called it claims. And then the last piece I want to show you is their dispatchable function that they wrote. So again, these are the functions that a UI, a DApp, or some other observer, a script, anything can call these functions on the block that exist on the blockchain. They called theirs create claim. Don't worry about this boilerplate for now. This describes transaction fees, and it's a really deep topic for Substrate. They called it create claim. They check and make sure that the origin, remember this is the caller of the function, is signed so that the person who clicked on this action, like say in their wallet, they are the account that did click this. They retrieve that account ID by getting it through here. The sender is now equal to the account ID of that caller. Okay, and now what they're doing is they're verifying that the specified proof has not already been claimed. So remember when I talked about the error that indicates whether a claim is already chosen by another, was already claimed by another user, this is where that comes into play. So we have this ensure function, which is like an assert in other languages like JavaScript. We're asserting that our proofs storage, okay, so proofs is, again, this piece of storage that we said ties a file to its user and block number. This piece of storage does not contain the key or the file hash. So we're going to query by that key, which is the file hash. And if we get nothing back, we're good. The user can now submit the claim. If not, we spit back the error proof already claimed. We get the block number using a handy function that Substrate exposes. And now we're coming back to our storage item. We're saying, okay, this is all good. We can now store it in this storage service. We're going to call insert on it with our key, which is the new file hash, and our tuple of the sender's account ID and the current block. Finally, this is all done. So we want to tell the UI, hey, this action was done on chain in this transaction. So here it is. We have the claim created event with this sender and this file that they've given as proof. So apologies if that's a lot. Let's look at it in action. So what we're looking at now is a front-end DApp interface that's like a React-based general starter template that has a bunch of different components for interacting with a locally running Substrate chain. I have the solution running locally, so that's what you're seeing happening now. This React component here at the bottom called proof of existence allows us to run through this functionality. So I'm going to test uploading some random file on my machine. The front-end library makes a query here. So separate from any extrinsic that we've written, it makes a query that says, hey, is this file hash, does a key exist on the storage map? If not, I'm gonna show this right here. And we're able to create the claim. So since our front end told us that it's okay, so it went ahead and it submitted the transaction and put my transaction in a block. As you can see here, we have the account ID of this person. This is a development account. These are not real people, but this is like essentially a wallet or account selector. So we've designated Alice as the owner. This is the digest, I believe, the block that it's on. And then finally, when it's finalized, when it's ready to say it's valid, it gives us the block hash that it's in. And just to wrap this all up, the event that we created, or the one that we intended to create, called claim created, the piece that we created so that we can inform the front end of what happened, fired here, and it said, this account made claim to this file digest. So a lot of this is kind of boilerplate. Again, like this part of the app is just kind of an example app that's part of a front end template, but it's a good way to show off the interactions of this, this example blockchain runtime. I'm running out of time, so I'm going to stop there and take any questions. And I can show you my final slide, and then we can call it a night.
One question I had is, what does it look? You mentioned dispatch functions briefly. How does that work with tying in the code to the front end?
So let me make sure I understand. Your question is around us writing these dispatchable functions, and are you wondering how the front end knows about?
Yeah, like how would you call it an API to like a contract deployed, basically?
Okay, so yeah, it's a good question. So in so the front end library that's written here, it's called Polkadot.js, and it knows a number of ways to call substrate based chains. And a few things that are common to substrate based chains are there's an API for getting the pallets in your runtime, so you can query for the pallets. So in this example, if I was an app, if I was on the same development team, I would know the name of my pallet. If you didn't, you can query for the pallet and get the name and get its. You can also get its exposed dispatchable functions. If you're on a team and you're in the same code and shared code bases, you'll obviously see the dispatchables, and you'll write them in your Polkadot.js code. It's almost the same. It's just JavaScript style, like it's a camel cased pallet dot dispatchable function. I hope that answers your question. It's a way to there's a number of ways to query for the exposed functions.
Yeah, so Polkadot.js handles kind of the back and forth between the chains and front end code.
Yeah. So that maybe that's the answer to your question.
Sorry.
Yeah. It's able to handle those interactions. It knows all the proper encodings. When you initialize Polkadot.js, you'll initialize it with like a WebSockets, URL, WebSockets address for your node, if you know the node, and it initializes, and it's able to like deduce the types that you've created in your substrate chain, so it knows how to convert to Rust types. And yeah, it's able to figure out your pallets.
A question in the chat.
Oh, I'm sorry. So the blockchain doesn't store the file, but only the hash of the file. So it says Alice owns that particular hash. Is that correct? You are correct. In this case, for just the keeping a nice scope of example, we're assuming that in this case, we're assuming that some other, maybe a decentralized file storage system is used, like IPFS or something like this. Working with actual file storage with a blockchain might be difficult, just because when you're designing storage or you're just storing things on a chain, you want to focus on like some really consensus critical storage values. So if you're dealing with something like files, you might not want to store the whole file, but if you can think of a way to design your application that would not involve you having to store a whole file, but instead do something like point to a file, it's far more desirable to design an application or a chain that would work that way. So yes, this example kind of operates with that understanding. Yeah, in this case, when we say Alice owns that particular hash, yeah, we're kind of saying in an application where you're doing some kind of file storage thing where you have a storage solution and you have some tracking of ownership on chain that's split up from the actual storage. This is how we say Alice owns that hash. Cool, I hope that makes sense. So as far as getting started, we're ending like right at the hour here. You know, my introduction is kind of contrived. I tried to communicate quite a lot here. Luckily, the tutorials are way more self-paced. You know, you can just follow along. And they walk you through every step from installation, cloning the repo, you know, some common syntax and things like that. Best starting point if you're really interested in learning Substrate and you don't know Rust, start with the Rust book. It's a great, it's like the canonical way to start Rust. This is how I learned Rust and kind of got into the space. If you're looking to build, you can start with the docs. We have all the Substrate syntax. We have links to code documentation. And we just launched a new doc set, docs.substrate.io. And also there's the tutorials. I highly recommend the tutorials because they give, you know, not only are you being walked through how to do the building step by step, but, you know, tutorials attach like a value to what you're building. Like for this example, we're building some file ownership related service, and that's the POE tutorial. All the tutorials work like that. You're either implementing smart contracts or you're, you know, doing some NFT, kitties example, that sort of thing. If you're stuck, we offer support. We got a new stack exchange for Substrate. We have a matrix chat if you're interested in like a decentralized medium. Otherwise, we're also on Discord. And there's a number of Stack Overflow questions and a Substrate tag. Finally, there's examples on YouTube. There's Substrate seminars which occur bi-weekly now, or at least monthly, and these cover really interesting topics like building tutorials like the one that we covered, interviewing builders in the space on what they're building, interviewing members of Parity if they're working on new features. So like things like cross-chain messaging or smart contract implementations or decentralized knowledge graphs, for example, are some interesting topics that came up in the past few weeks. But that's all I have. So I want to thank you guys for sticking around.